This instruction video will focus on actuator saturation, a problem you will always encounter when implementing controllers. This is the standard feedback control scheme. P is the plant to be controlled, C is the controller. To manipulate the plant, the controller needs access to a so-called actuator, which is the input we have defined for our plant. When designing a controller C, you have to take into account that this actuator will always have physical limits. In other words, a controller can never put infinite power into a dynamical system to manipulate its behavior. Furthermore, we don't want actuator saturation, as the behavior of the system becomes nonlinear in that case, and all our linear system modeling, controller design, and performance analysis will not be valid anymore. In case of the ball levitator, the actuator is the power electronic that acts as a current source, creating the current through the coil. The power electronics has an upper limit of 3 amperes and the lower limit of 0 amperes. However, the controller you have to design will act around the operating point defined by I0 and Y0. The operating point you've used to linearize your plant. I0 will affect the controller upper and lower control range. If I0 is not centered at 1.5 amperes, the controller range to increase the current will be less than the range the controller has to decrease the current with respect to I0. So with respect to the operating point I0, the linear controller has an upper limit of 3 minus I0 and a lower limit of minus I0. You will typically use the Sisu tool in MATLAB to help you with the controller design. There are a couple of things you can do to take actuator limits into account when working in Sisu tool. First, select the Edit Architecture option in the Sisu menu bar. This will open the following user interface. Here you find the plant input U, which is the signal for the plant actuator, and R, which is the reference signal you want your controller to track. So in this case, a desired position of the ball around its operating point. To see if the controller causes actuator saturation, you can examine the R to U step response. When producing time domain responses, Sisu tool will always use a unit step for R. So this is basically one edge of a square wave with an amplitude of 1 meter. To make this more realistic, you can change the default value of f, which is 1, to for example 0.0008, which means that the reference step that you want the system to track now becomes 0.8 millimeters. Next, you can examine in Sisu tool the plot of the step response of R to U, so from reference input to controller output, to see if your controller causes actuator saturation. In this example, the sum of the peak current at T is 0 and I0 must stay below the actuator upper limit of 3 amperes.